Somewhere in the last 24 hours, you stood on it. The sidewalk outside your building, the floor of your parking garage, the bridge you drove over without looking up. And you didn't think about it once. Nobody does. Concrete is the most boring thing in your entire life, and also the second most used material on Earth, second only to water. The world pours something like 4 billion metric tons of cement a year, more than half a ton for every human alive. And here's what stopped me cold the first time I ran the numbers. That stuff sells for around $150 a ton at the plant gate. A decent pair of running shoes costs more than a ton of the material holding up every building you've ever walked into. So how does anybody make money selling that? I've spent 15 years on the industrial side of finance, and I'll give you the punchline right now, because it reframes everything. When you buy a cement plant, you are not buying a factory. You're buying a circle on a map. Whew! Let me show you what I mean. First time I walked into one of these, I was 28, doing diligence on a mid-Atlantic plant a client wanted to buy. The guy running it was Ray Kowalczyk, third generation. His grandfather worked the kiln floor, back when the Lehigh Valley was basically the Saudi Arabia of American cement. Ray meets me at the gate, looks down at my shoes, and says, "Those are going to be gray forever." He was right. I threw them out. Then he walks me up on a catwalk and points. Picture a steel tube, 300 feet long, 15 across, tilted slightly, slowly rotating. Inside, it's 2,650 degrees Fahrenheit, hotter than lava. That's the kiln. And what happens inside is chemistry we borrowed from volcanoes. You crush limestone, mix in a little clay, iron, and sand, feed it in the top. As it tumbles down through the fire, the calcium carbonate breaks apart, throws off carbon dioxide, leaves calcium oxide behind, which fuses into little gray marbles called clinker. Grind those with some gypsum, and that powder is cement. That's the whole product. Rocks that have been cooked and then recrushed. Ray said it better than I ever could. We're not manufacturers. We're a very expensive oven with a rock problem. Here's the thing about that oven, though. It never stops. A modern kiln runs around 330 days a year, 24 hours a day. You shut it down once, on purpose, usually in winter when demand is dead. Rip out the refractory brick lining and replace it. Planned outage. Costs millions. Everybody's fine with it. What nobody is fine with is an unplanned stop. Ray told me about a bearing failure that cost them 11 days. Cool a kiln too fast, and the lining cracks, the shell can warp, and you're into 6 figures a day before you've sold a bag of anything. So rule 1, the fire never goes out, which brings us to what it costs to light that fire. A new integrated plant in the US, call it 1.5 million metric tons a year, runs you north of $400 million. Some estimates push past $500 million, depending on site and emissions controls. In plain terms, you're paying roughly $250 to $300 for every annual ton of capacity, and you're selling that ton for $150. Running flat out with zero costs, it takes 2 years just to earn back the build. With real operating costs, you're looking at 10 to 15 years to see your capital again. That's a terrible business. On paper. And yet the people who own these things are printing money. So what am I missing? This is where my friend Dolores Manzetti comes in. Everybody calls her D. 20-some years running distribution terminals on the Ohio River, and she's the one who beat the real model into my head. We're in a diner in Cincinnati, and I'm doing what young analysts do, showing off a spreadsheet. She takes my pen, flips the placemat over, draws a dot, and draws a circle around it. That's your business. Everything inside the circle you own. Everything outside it you don't. And nothing in that spreadsheet changes the size of the circle. Here's why. Cement is a low-value, high-weight commodity, costs almost nothing per pound, and weighs a literal ton, which means freight isn't a line item. Freight is the whole ballgame. Trucking cement runs somewhere around 15 to 20 cents per ton per mile. Haul it 200 miles, and you've added $30–40 to a product that sells for $150. You just ate a quarter of the price in diesel. So a plant can only serve customers within roughly 150 to 200 miles by truck. That's your market, not the country, not even the state. A circle. And here's the beautiful part. Your competitor 250 miles away physically cannot come take your customers. Not because of branding or quality or some clever strategy, because of diesel, because physics said no. That's a geographic monopoly enforced by freight cost. Dee's whole career was about bending that circle. Barge freight costs maybe a tenth of trucking per ton mile. Rail sits in between. So if your plant's on a navigable river or you've got terminals at a deepwater port, your circle turns into this long, weird amoeba shape stretching down the Mississippi. A plant without distribution is a fortress with no roads. A plant with terminals is an empire. Okay, so if these circles are that good, why doesn't everybody just build a plant in an empty one? Now we get to the real asset. My friend Warren eBay runs a small private equity shop out of Dallas. Around 2014, he got obsessed with exactly that question. Found a market in the Mountain West that was structurally short on supply. Lined up a site with good geology, raised the capital, went for a greenfield plant. I asked him about it a few years back. He laughed and said, "I bought an education. Permitting a new cement plant here takes 7 to 10 years, sometimes longer. Air permits, mining permits, water discharge permits, local zoning, and everyone is a public process where anybody within 30 miles can show up and object." And they do, because nobody wants a cement plant near their house. Warren spent 4 years and a lot of money and never poured a foundation. The project died in a county hearing room. Here's what people miss. The US has somewhere around 90 to 100 active cement plants, and that number's been roughly flat or shrinking for decades. We don't build meaningful new greenfield capacity anymore. We expand and modernize what already exists. Because the permit is the asset, not the kiln. The kiln is just steel, and anybody with $400 million can buy steel. Nobody can buy 1,974. That's why these things trade below what it'd cost to build them new. Sounds like a bargain until you realize the reason isn't that replacement is cheap. It's that replacement is impossible. There's one more layer under all this, and I learned it from a geologist named Cliff Nakamura. Cliff walked me through a quarry in Central Texas about a decade ago, and 10 minutes in he says something that rearranged my brain. You know this isn't a factory, right? It's a mine that happens to have an oven attached. Every cement plant sits on a limestone deposit. Has to. If you trucked limestone in, the freight math I just described would kill you before you sold your first ton. So the quarry is right there. Sometimes a conveyor belt from the crusher. So when you underwrite one of these, the first question isn't the kiln, it's reserves. How many years of rock are under that ground? You want 50 to 100 years of proven reserves. Cliff told me he'd seen deals where a plant looked cheap on an EBITDA multiple and turned out to have 18 years of limestone left. 18 years on an asset with a 50-year life. He called it buying a car with the gas gauge painted on. And the flip side is just as real. Some of the most valuable cement assets in America are valuable because of what's beside the kiln, not in it. Aggregates. That same quarry sells crushed stone for road base and asphalt, sometimes at margins rivaling the cement, in a market where nobody else can open a quarry either. Same permitting problem, same moat. All right, where does the money actually go? Because the cost sheet here is strange. My go-to here is Priya Raghunathan, a process engineer I worked alongside on a restructuring years ago. Priya thinks in kilocalories the way most finance people think in basis points. She broke it down like this. Energy, fuel, and power together usually lands around 30 to 40% of cash cost. Labor is shockingly small because a modern 1.5 million ton plant might run with 100 to 150 people. Then maintenance, raw materials, and a mountain of fixed overhead. That's the trap. Most of your cost doesn't care how much you sell. Whether the kiln runs at 90% or 60%, you're paying the same people, the same debt, and heating the same enormous tube. But Priya also showed me the two prettiest cost tricks in heavy industry. First one is fuel. These kilns run so hot and hold material at temperature so long that they destroy essentially anything you put in them. So you burn waste, shredded tires, used solvents, wood chips, non-recyclable plastics. And here's the kicker. Sometimes you don't pay for that fuel. Sometimes somebody pays you to take it. Sit with that. Your largest input cost can go negative. Your competitor is buying coal at market price, and you're getting checks to accept the fuel you burn instead. In parts of Europe, plants run 50, 60, even 80% alternative fuels. In the US, that number has historically been way lower, maybe the mid-teens, which is either a failure or an enormous pile of margin sitting on the table, depending on your mood. The second trick is chemistry, and it's better. The expensive part of cement isn't the cement, it's the clinker. Clinker needs the fire, the fuel, the emissions permits, all of it. So if you could make cement with less clinker in it, you'd be adding capacity for free. That's exactly what happened. The American industry shifted hard toward Portland limestone cement. Type 1L, grind extra limestone in with the clinker. Cut clinker content by roughly 10%, essentially the same performance in most applications. 10% less clinker means lower fuel per ton, meaningfully lower carbon. And here's the finance part. The same kiln makes more sellable cement. Priya said it best. We just gave every plant in the country a capacity expansion, and it cost nothing but paperwork. So this all sounds great. Geographic monopolies, negative cost fuel, free capacity from chemistry. Why isn't everyone rich? Because of what happens next. Cement demand is a leveraged bet on construction, and construction is the most cyclical thing in the American economy. Not correlated, leveraged. In 2006, the US consumed roughly 128 million metric tons of cement. By 2010, that had collapsed to around 70 million, 45% gone in 4 years. Now go back to Priya's cost structure. Mostly fixed. The kiln keeps running or you damage it. Debt service doesn't care about your volumes. Ugh, I lived that one. I was working a book of industrial credits in 2009, watching producers who looked like fortresses in 2006 go from 30+% EBITDA margins to roughly zero. Some went negative. Plants in this country sat idle for years. Cold, mothballed. Hundreds of millions of dollars of steel in a field, doing nothing. That's the part spreadsheets don't capture. You can own an unbreachable local monopoly and still get wiped out, because a monopoly on a market that stopped existing is worth nothing. Rough rule I use. These assets break even somewhere around 60 to 70% utilization. Above 80, they're extraordinary. Below 60, you bleed. And there's not much you can do, because you can't shrink a kiln. And then there's the thing that shows up right when you're weakest. Imports. We don't make all the cement we use. In recent years, the US has imported on the order of 20% or more of consumption, landing at coastal and river terminals from Turkey, Canada, Vietnam, Greece. And imported cement doesn't respect your circle. It lands at a port and starts its own, right on top of yours. Which is why this industry has basically lived in trade courts since the 80s. Let's go downstream for a second, because most people get this piece backwards. My friend Hank Delgado runs Ready Mix concrete trucks in Phoenix. Ready Mix is the guy who shows up at the site with the spinning drum. Hank explained the constraint that defines his whole life. Once water hits the mix, he's got 90 minutes. After that, it's setting up in the drum, and he owns a very expensive rock sculpture. So if the cement plant's circle is 150 miles, Hank's circle is more like 25. And that tightness is exactly why the big cement companies bought guys like Hank. Vertical integration. Own the plant, the ready mix, and the aggregates, and you capture margin at every step. More importantly, you guarantee yourself a customer who can't shop around. Hank's take was blunt. The cement guys don't need me. I need them. There's one plant that can reach me on cost, and they know it. That's what pricing power sounds like in real life. It's not a chart. It's a guy in Phoenix with one realistic supplier. But there's a bill coming due, and we should be honest about it. Marguerite Ose, a friend of mine, works in industrial decarbonization, and she's the one who made me take this seriously. Cement is responsible for around 7 to 8% of global carbon dioxide emissions. Not construction, cement specifically. If cement were a country, it'd be the third or fourth largest emitter on Earth. And here's what makes it uniquely hard. Roughly half to 60% of a plant's emissions have nothing to do with fuel. They come out of the limestone. Calcium carbonate breaking down releases carbon dioxide. That's not a combustion problem you fix with solar panels or hydrogen. That's the reaction that makes the product. Marguerite put it this way: you can decarbonize the fire. You cannot decarbonize the rock. So the only real answer at scale is carbon capture. And it's starting. Heidelberg Materials brought a full-scale capture facility online at Brevik in Norway, the first of its kind on a cement plant, and there are U.S. projects in development, helped by the 45Q tax credit, which pays up to $85 a ton for captured and stored CO2. But retrofitting capture can cost hundreds of millions per plant and add real operating cost per ton on a product that sells for 150. So here's the hard question. Does carbon regulation destroy this business or become the deepest moat yet? If compliance costs $300 million a plant, that's just another wall a new entrant has to climb. Europe's already headed there with border adjustments that price the carbon in imported cement. The incumbents may end up thanking the regulators. Wouldn't be the first time. So let's land this. What is owning a cement plant, really? You're buying an asset that costs $400 million plus to build and takes a decade of permitting you probably can't get. It sits on a mine that needs 50 years of reserves. It runs a fire that can't go out. Its market is a circle drawn by diesel, and inside that circle you're close to untouchable. In good years, the best of these throw off EBITDA margins north of 30%, and an operator with terminals and downstream ready-mix compounds that further. In bad years, volumes fall 45% and fixed costs eat you alive. So it's not a growth business, never will be. It's a toll booth with a construction cycle strapped to it. You're not paid to innovate. You're paid to own something that cannot be rebuilt, standing where nobody else is allowed to stand. And that's the lesson I've carried from cement into every other industry since. The most durable businesses in America are almost never the exciting ones. They're protected by something boring and immovable. A permit, a river, a pile of rock, 150 miles of asphalt between you and the nearest competitor. Ray said one more thing on that catwalk that I think about maybe once a month. He looked out over the quarry and said, "Everything you've ever loved was built on top of this, and you've never once wondered where it came from." He was right about that too. So next time you're stuck on an overpass, look at the gray stuff. Somewhere within a couple hundred miles of you, there's a tube of fire that never stops turning, sitting on a hole in the ground somebody got permission to dig 50 years ago, and it's quietly one of the best businesses in the country. If you got something out of this one, hit subscribe, because I'm working through this whole series, one industry at a time, and I'd like you along for it. Drop a comment with the business you want me to break down next. All the data sources for this episode are linked in the description if you want to check my math. I'll see you in the next one.